another video. So in this one we are still continuing on the IUPAC naming of the organic compounds. Okay, so now we are on alkynes. So alkynes, they are very much similar to alkenes. If you remember how we were naming alkenes, it's the same thing. The only difference here is that these ones now, they have triple bonds instead of the double bonds, right? And then with alkynes as well, they are also unsaturated hydrocarbons, and then they have a different general formula compared to the alkanes and the alkenes, right? If you remember our table, we had a table here. If you remember our table, right, so for alkynes we said we have CnH2n minus 2, right, as the general formula. So now at this point we have pretty much talked about all the hydrocarbons. Remember, we said hydrocarbons are all the organic compounds that only contain carbon and hydrogen, hence the name hydrocarbons. Hydro for hydrogen, carbons for carbon, right? So alkynes are the last list on the hydrocarbons. All right, and then after we will focus on haloalkanes, alcohols, carboxylic acids, esters, aldehydes, and then lastly ketones. All right, so there will be similarities in these organic compounds. So now, yeah, let's deal with the alkynes. All right, so like we said, these ones, they are unsaturated hydrocarbons. They have a general formula CnH2n minus 2, and they have triple bonds. All right, so let's put that information here. All right, so the triple bond I mean is the functional group of alkynes, right? Remember alkynes, or remember a functional group, it's basically a bond, an atom, or a group of atoms that get to determine the physical and chemical properties of a specific organic compound, right? So in this case, the functional group of alkynes is the triple bond itself, right? Whereas in alkenes it was the double bond, in alkanes it was then the single bond. Now the suffix also changes. It's YNE now, right? Remember, for alkanes it was ANE, for alkenes it was ENE. For alkynes the suffix is YNE. All right, so but everything else, the naming, we will follow pretty much the same structure as we did when we were naming the alkenes, right? And also the alkanes. But on the alkane side, we will take the naming of the alkyl groups and do the same thing on alkynes, right? So here are some of the rules for naming alkynes. As you can see, it's pretty much the same as when we're doing the alkenes, right? So here you still do the same thing. You choose the longest continuous parent chain which contains the triple bond. What that means is if the chain that you are choosing, or the carbon chain that you are choosing, does not have a triple bond in it, then it's invalid. You can't use it as the parent chain. The parent chain must have the triple bond, and then you start numbering from the side which would allocate the lowest number to the carbon-carbon triple bond. So you must make sure that whichever side you start numbering your chain from, that side will give you the lowest number compared to the alternative side. So in this case, if you start numbering from left going to the right and you compare it to right going to the left, one of the two must give you a lower number than the other. Okay, so that's what we've been doing with alkenes as well, if you remember all of our examples. And then of course we separate numbers by commas, and we separate numbers to letters by the hyphen dash, this one, right? I just didn't edit here, but you'll see it. And then the substituents or the alkyl groups are named as in the alkanes, as also in the alkynes. Okay, nothing changes there. All right, so now let's look into how we name the parent chains in alkynes. Remember, there will be the parent chain, and then we count how many carbon atoms it has. Then we get the stem name corresponding to the number of the carbon atoms in that chain, and then from there we combine that stem name with the suffix of that homologous series. In this case, the homologous series that we are concerned with is alkynes. All right, so let's look at that table. All right, so when we want to name the parent chain of any alkyne, we use Y and E as the suffix, but we add it to the stem name. Remember, the stem name is dependent on how many carbon atoms are in the chain. So if that chain has only one carbon atom, the stem name will be meth. And then if it's an alkyne, we add a suffix Y and E, so now it becomes methine. Okay, if it has two carbon atoms, the stem name will be eth. If it's an alkyne, like in this case, we add our suffix Y and E, it becomes ethine, and so on and so forth. Propyne, butane, pentyne, right, all the way until decyne, which is when the carbon chain has 10 carbon atoms. All right, so that's what we do. That's how we name them. All right, so now the best way to do this one is to just go straight to the examples, and then we start naming, because we've learned pretty much all the techniques for naming these things. It's similar for alkenes and alkynes, so we'll just jump straight to it. Okay, all right, let's start with this example. Okay, so this is an alkyne, right? If you see here, if you check, we have a triple bond there, so this tells us that we're dealing with an alkyne. Now, how do we name it? Remember, rule number one, we choose the longest chain, the longest continuous chain. Continuous is the keyword, and longest, right? And then secondly, that chain must contain the triple bond in it. If the triple bond is not there, we can't use that chain because it's pretty much invalid. All right, so here it's quite clear. Our longest chain will be this one, right? It's just going to be this one. Now, so now what we can do is we can start numbering from the side that will give us the least location of the triple. All right, let's assume we start now. Okay, for this one it's a bit obvious though, but if we were to take it step by step, we would say if I number from left to right, okay, I go from left to right, I say 1, 2, 3, 4. Now the carbon triple bond will be on the third carbon, this one, right? So whereas if I number from the right to the left, I would go 1, 2, 3, and then 4. Here the triple bond is on the first carbon, which is this one, right? So it's clear that I have to number from the right to the left, right? So there are no alkyl groups, there's no branch or a substituent of any sort. All right, all right, so that's the chain we have. It has 4 carbon atoms. So if it has 4 carbon atoms, the stem name is but, and then we add our suffix, which is Y and E. So this would be butane or 1-butane, right? We can even use our template from the alkenes. Remember, we had a list of things, and then at the end we will just write the name. Let's bring it here, right? So this is our template. We would say, so we decided to number the main chain, in this case from left or right to left, right? Of course, in an exam you don't have to say all these things, but this is just to help you understand why we do certain things in this IUPAC naming. Right to left, right? I'm just matching the colors here, and then this side is nearest to the double bond compared to when we were numbering from left to right. Okay, so now how many carbon atoms are in the main chain? We found that there are 4, and then the position of the triple bond, it's on the first carbon atom, so it's number 1. It's on the first carbon atom. So what is the name of the main chain? We know that it's butane. Why? Because since the carbon chain has 4 carbon atoms, it will have a stem name of but, and then from that stem name we add our suffix YNA, so we get butane. Right, that's how it looks like. Or our suffix is YNA. Right, for alkynes our suffix is YNA always. All right, so this was from the template from the previous problem, so let's remove that. So now the full IUPAC name for this one is, first of all, we don't have an alkyl group, so we won't start with that one. So we will go straight to the location of the triple bond. So it's on number 1. So we will call this one I think we should stick to the same 1-butane. So that 1 tells us along the main chain at which carbon atom can we find the triple bond. At carbon atom number 1. That's why it's called 1-butane. Or remember, there are 2 ways of naming these ones. You just say but, which is your stem name. You separate it with a dash, because remember, you separate words and numbers with dashes or hyphens. 1 for the location of the triple bond, and then you put your suffix. It's but-1-ine. Yes. So let's go to our example 2. Here we can take the same templates that we have here, just so that. Alright, so now we have this chain or this alkyne. Right, so now let's identify our longest continuous chain. Of course, it must contain the triple bond, otherwise it's invalid. So let's start by checking this one. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Right? The straight one is 7. 1, 2, 3, 4, 5, 6, 7. Even the L-shaped chain is 7. So you know what I always do? I just take the straight one for my own convenience. So our longest chain will be this one. Our main chain will be that one. Okay, so that's our main chain. Now let's see, if I start numbering from left to right, I'll get 1, 2, 3, 4, 5, 6, and then 7. So if it's 7, the stem name will be what? Hept. Right, let's come and check here. Hept is our stem name, so this long chain will be heptine. The name of our main chain will be heptine. Hept is the stem name. The suffix for all alkynes is YNE. We combine the two, we get heptine. Now, if we number from right to left, this will be 1, carbon 2, carbon 3, carbon 4, 5, 6, and carbon 7. So when we number from left to right, which is the one up there, the numbers up there on top, we get that the triple bond is on carbon atom number 2, But if we number from right to left, we get that the triple bond is on carbon number 5. So clearly we should number from left going to the right, because we get the lowest number. So we'll number from left to right. It's better than numbering from right to left or east. It's better than numbering from east to west, if you want compass directions. So right to left. All right, so that's what we have. And then now if you check, that's our main chain, but there's a branch here or a substituent. This is an alkyl group. Remember from all our naming, when we were naming alkanes and alkenes, we had these alkyl groups. So the name of this one, since it has one carbon atom, it's methyl. It's the methyl group, like this, right? Because it has one carbon atom. So now that we have all those pieces of information, we can then start filling our things. Okay, so here, since we have an alkyl group, we can just put it, okay, let's put it here. Right, so here we can just add name of alkyl group. Right, so now we have our templates. Of course it would look nicer if it was a table, but this should be, it's just to make sure our minds have all the information that we need, right? So the number of carbon atoms in the main chain, we found 7. The location of the triple bond, we said it's on the second carbon atom. And then the name of the main chain is heptine, because it has 7 carbon atoms. So the stem would have been, or is actually, the stem is hept, and then you add that stem with the suffix, which is y and e, and then you get heptine for the main chain, the name of the main chain. So the location of the alkyl group, it's on carbon number 6, because we are numbering from left to right. So carbon number 6, that's where you'll find the alkyl group. And we said the name of this alkyl group is the methyl group. So like we've been doing for alkenes, alkynes will also behave the same way. Like we've been doing for both alkenes and alkanes, when it comes to the final name, we start with the methyl group. So we start with the alkyl group or the substituent in front of the name. So its position and its name first. So this will be the position of the methyl group is on carbon number 6. So this will be 6. Remember, we separate numbers and letters using hyphens. So this methyl, right? And then from here you can then put how far or where is the triple bond located along the main chain. It's on carbon number 2, carbon atom number 2. So we put our 2 there. Then we put the name of the main chain itself, which is heptine, right? Or why is it down here now? Oh yes, can move it slightly. Right, or we use our other naming method where we say 6-methyl hept 2 y and e. So you can use one of these two. So the first one, you just tell us the location of my alkyl group along the carbon chain is number 6. What's the name of my alkyl group? It's methyl. Okay, now where's the location of my triple bond? It's on carbon number 2. And then what's the name of the main chain where all of these things are located? It's heptine, right? Or you do it the other way around. Okay, so it depends on your preference there. There's no right or wrong way, as long as, of course, your naming is correct, then you'll be correct as well. All right, so let's continue to our another example. All right, this is our number 3 example. All right, so now here we can just trace our chain. Okay, so let's start with the straight one. How many carbon atoms do we see there? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the straight chain has 8. Okay, of course, remember, we don't check if the chain won't contain the triple bond, because it's useless. We need it to have the triple bond. Okay, all right, so now let's check the other one. 1, 2, 3, 4, 5, 6, 7. Okay, this one is a lower number, so we can't say 1, 2, 3. Okay, this one is even shorter, so it doesn't really matter. But if it was long and going all the way there, we can't use it because it leaves our triple bond there, so it won't be part of our long chain. So whatever chain that we would be creating there will not be valid actually. So we only focus on the ones that will have the triple bond being part of them. So we've already established that the straight one will be the best option, so we'll go and mark it. Our straight chain has 8 carbon atoms. Okay, all right, so we have something like this. Now that's our main chain. So now let's start numbering. Remember, we want to number such that the triple bond is located in the lowest possible, or in our numbering puts the triple bond closest to wherever we start numbering from. So if our position 1 is here, the triple bond must be as close as possible to our first carbon atom, if not already in the first carbon atom. Or if we start numbering from this side, the triple bond must be closer to that side. So how do we test that? We basically say, what if we number from right to left? Of course, with enough practice, you don't have to do it step by step. You can just look at it and see that this thing, it's closer if I number from this side going to the other side, right? But if you are still practicing, it's okay to test both, right? Also, there you won't really need to write them down, but I'm writing them down here so that you can get the idea. All right, that rhymed. So now we start from left going to the right. So 1 carbon atom number 1, 2, 3. So when we're numbering from left to the right, the triple bond will be on carbon number 3. So we continue 4, 5, 6, 7, 8. All right, so now let's see if we number from right going to the left, because now we were numbering from left going to the right. Okay, this will be 1, 2, 3, 4, 5, 6, 7, 8. So when we number from left going to the right, which are the numbers at the top, we get that the triple bond will be on carbon number 3. But then when we number from right to the left, which are the numbers at the bottom, we get that our triple bond will be on carbon atom number 5. So clearly the best one is to use these numbers. So we must number going that way. Must number going that way from left to right. All right, so let's go and check if we have any substituents or alkyl groups, and of course we do. I see one here. This is our methyl. I see another one here. Remember why it's methyl, it's because it only has one carbon atom. I see another alkyl group here. This one, since it has two carbon atoms, we call it an ethyl group. Alright, so we have two alkyl groups. One is methyl, the other one is ethyl. Alright, so we said it's better we number from left to right. Let's start filling our templates. Left to right compared to when we number from right to left. Or it's better to number from west to east compared to numbering from east to west. Alright, so how many carbon atoms are in the main chain? Remember, we found them to be 8. The location of the triple bond, we said it's on number 3, this one. Carbon atom number 3. What is the name of the main chain? The main chain is 8, so it has to be octine. So octine, because 8 has the stem name oct, and then when we add the suffix to it, we then get octine, because the suffix is YNE. That's where it comes from, okay? Now, what is the location of my alkyl group? So I see that I have 2 alkyl groups here. Let me see if I can use this. So I have 2 alkyl groups. Right? Right? So the locations of these alkyl groups, it's number 2 and number 4. If you check here, there's one at number 2, which is the methyl. There's one at number, oh my bad, number 5, which is the ethyl. Alright, so we have number 2 and number 5. So it's 2 and 5. Then the names of these is the ethyl, which is the methyl, which is number 2, and ethyl, which is number 5. Alright, that one is that one. Okay, so from here onwards, we can then now start getting our full IUPAC name. So remember, we start with our alkyl groups. So even when we start with our alkyl groups, we prioritize them by order of their alphabetic arrangement. So for instance, E comes before M in the alphabets, right? So therefore, when we name this organic compound, we will start with ethyl. So what we do is we come here and we say, yeah, it's fine, let's put it like this. We say this will be, what's the location of ethyl along the parent chain? Ethyl is on number 5, right? It's number 5, so this will be 5 ethyl. If there were 2 ethyls, it would be 5 point something. Let's say the other one was also in position 5, it would be 5.5. Then we would say diethyl, because there's 2, or there are 2. So we start introducing these Greek prefixes when we have a repeating or an identical alkyl group. Okay, if you have forgotten, you can go back and check our video on alkynes, where we were naming not alkynes, I mean alkenes, where we were naming alkenes that had repeating or identical alkyl groups or substituents. Alright, so in this case there's only one, and then we add our other alkyl group. since it will have its number as well, we put a dash or a hyphen, then we put its location, which is number 2, and then its name, which is methyl. Now we can start looking at the position of the double bond and finally the name of the parent chain. Position of the, not double bond, triple bond is number 3, carbon atom number 3. So we put it here. And then now the name of the parent chain is octine. Okay, so this is how we would do it. Or, remember, there's always an or we would say 5-ethyl 2-methyl oct 3-YNE. Okay, that's how we would do it. Right, so this is how we would name these organic compounds, these alkynes. All right, okay, so let's check our other example. All right, so we have our template ready, and then we can start with our other example, example 4. So here we're just giving a condensed structural formula. So now let's find our longest chain. If we start with the straight one, we get 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms. Okay, this is also some octine. And then if we go to any branching one, 1, 2, 3, 4, 5, 6, 7, 8, we still get 8. Okay, if we go to, there's another one, this one, 1, 2, 3, 4, 5, 6, 7. Okay, this one won't work. So the highest number we've got, or the longest chain we've gotten, is one that has 8 carbon atoms. So this one will eliminate it. And then we can come again, 1, 2, 3, 4, 5, 6, 7, 8. All right, so the straight chain still works here. It has the longest, which is 8 carbon atoms. So we can just mark this one as our straight chain. Right, so from here we can then start checking where is it best to start numbering from. If we number from left to the right, we go 1, 2, 3, 4, 5, 6, 7, 8. So here the triple bond is on carbon atom number 4. So now if we number from the opposite direction, which is right to left, we get 1, 2, 3, 4, 5, 6, 7, and 8 again. So here the triple bond is still on carbon atom number 4. All right, so then now how do we then choose which side to number from? So what we do is we check our groups. If you check here, this is group number 1, the alkyl group. Since it has 2 carbon atoms, this will be an ethyl. This is also another group. Since it has 2 carbon atoms, it will also be an ethyl. Then we have another group here. It has 1 carbon atom, so this will be a methyl. Right, so we see that alphabetically E comes before M, so we will therefore start numbering from the side which will place an alkyl group closer to where the alkyl group is closer if we number from that side. Okay, so in this case the ethyl group is closer, and also since we will be using alphabetical preference, so we prefer starting on the side that will put ethyl closer. So the reason for choosing ethyl is because E comes before M, so that's why. So we'll therefore start from right to left. instead of going from left to right. Reason for that, this side is nearest to the ethyl alkyl group. Compared to numbering from left to right. So remember, the triple bond will always take the preference. So in this case, we are using the substituents to decide which side to number from after we have considered the triple bond. Otherwise the triple bond starts always. The triple bond is preferred. All right, so in this case, when we were numbering from either side, we noticed that we end up having the triple bond being located in the same carbon atom number, or in the same location. So for instance, when we go from left to right, it's on carbon atom number 4. When we go from right to left, it's still on carbon atom number 4. So we then decided to, let's check now the alkyl groups. So that's the only time you would use alkyl group preference. All right, so how many carbon atoms are in the main chain? We found 8. Location of the triple bond, we said it's on carbon atom number 4. Now, what is the name of the main chain? It would have to be octine. We have seen similar ones before. What is the location of these alkyl groups? Okay, it's 2. No. It's 2, 3, and 6. So it's 2, 3, and 6. If you check, let's just highlight them. 2, 3, which is the ethyl, 2 is for the methyl, and then 6. Okay, 2, 3, and 6. What's the name of these alkyl groups? So we have an ethyl. So let me name them according to how they appear. With ethyl, actually it starts with methyl, which is the number 2. Then we get ethyl, which is a number 3. Then we get ethyl again, and another ethyl, which is the number 6. Right, so that's what we're getting now. Now, what's the full IUPAC name? It's gonna be an interesting one. So here, remember, we start with ethyl. Why? Because E starts, or E appears first before the letter M in the alphabet, right? So let's go. So if you check, ethyl appears twice. So we will do what? We will separate its locations using a comma. So it's gonna be the first location, which is 2, followed by its second location, which is 6. Then now we come and write diethyl. Why? Because there are 2 ethyl groups. So we have to use di to represent these 2. Remember the Greek prefix. There's di, there's tri, there's also tetra when you have 4. All right, so methyl is next. Methyl is at number, oh, we made a mistake here. Ethyl and ethyl are on 3 and 6. Then methyl is on number 2. We put our methyl there. And then finally, we write the location of our triple bond. We found it to be on carbon atom number 4. And then the name of the parent chain, that's octine. Or, as always, we have an option of saying 3.6 diethyl right? And then 2-methyl, right? And then finally you say opt for YME. That's another option. All right, so that concludes this example. So if you check everything that we're doing, it's the same as the alkenes, and naming the alkyl groups is the same for alkenes, alkynes, and alkanes. All right, so nothing much has changed. Naming the parent chain is still the same. We take the stem, which is decided by how many carbon atoms are present in the parent chain, and we combine it with the suffix of that homologous series. And in this case, the homologous series that we are concerned with are the alkynes. Remember, there's alkenes, alkenes, and now we're on alkynes. All right, so we can check our last example, which I want us to check how to sketch, how to draw the structural formula when you are given a name of an alkyne. How would you go about drawing the structural formula? All right, so let us check this one. So we're told to draw the structural formula for the following alkyne. So it's 3-ethyl 3-methyl pent 1-YNE, right? Remember, what I always say is start with the length of the parent chain. So pent means it has to be 5 carbon atoms in the parent chain. So you can go ahead and say 1, 2, 3, 4, 5 carbon atoms. Okay, now we are also told the location of the triple bond. It's on the first carbon atom, so you can either put it here, right, or put it there, because you get to decide which side you'll start counting from. So in my case, I'll just decide to put it this side. 1, my triple bond is here, the first carbon atom, which is this one, number 1. Then I'll be left with 1 bond here, so I can put my H there. Now they tell me that ethyl is on number 3, so if I go 1, 2, 3, it's here. I can come here and put my ethyl 1. Remember, ethyl has 2 carbon atoms, 2. Then you can put your hydrogens there. Okay, and then now we go for methyl, which is also on number 3. So I come here. Sorry if my bonds look long, just trying to make the structure neat. Sometimes the H's, they start being cluttered in one area and it looks messy. All right, so this is what we have, and then we can then now add H's where they are missing. That's how you draw the structural formula. Again, you start with the length of the carbon chain. In the name, you just go there, you look for the length. If you check here, we said this one, that's the length of the carbon chain. Okay, length of the parent chain or the main chain, right? And then here we got the location of the triple bond, right? Here we got the location of alkyl groups. So we'll just say the location of methyl and the location of ethyl. Right, so the location of ethyl and methyl. So that's it. Then you just start sketching your things. So your answer would be that one. That's our answer. Okay, so yeah, you can even start counting your carbon and hydrogen atoms just to make sure you have 1, 2, 3, 4, 5. That's pent. Can come and confirm in our table for the parent chain names, where our table was. So you can see that pent is actually 5, the pentyne. So we are fine. All right, so this concludes our examples and for alkynes. Yes, I'll catch you on the next part of this organic chemistry series.